So this is a new equation on the notes page, and I want us to look at it in Desmos to see what we have. So I want you to pay attention to a couple of things. What's the center of this graph? Then I want you to think about the shape. This is not a circle. It's more of an oval, right? And so it has a long axis going one way and a shorter axis going the other way. So it's kind of like two different diameters, two different radii. Oh, it's a horrible way to word it. But let's mark down how long, how far the edges are away from the center. So I'm going to make those notes onto my paper, and then we'll go back to the paper. So I'm going to put down that the center is 0, 0, and that the horizontal distance is 5 steps from the center. So, lack of a better term, the horizontal radius, I don't want to use the word radius, but I'll say horizontal distance. Then vertical distance from the center is 3 steps. And we're going to look at why that is. So from the information we got in our little investigation, we found that the center of this graph was 0, 0. The horizontal distance from the center was 5, and the vertical distance was 3. This is actually called an ellipse. And I want you to see kind of what happens if I take that equation and divide both sides by 225. So 9x squared plus 25y squared equals 225. If I divide both sides by 225, we get something kind of interesting. So 9 over 225. Well, 225 is actually divisible by 9. So that means I'm going to have x squared over 25. And then, well, that means 225 is also divisible by 25. That's going to leave me a 9. Whoops, that should be a plus in the denominator here and a 1 on that side. This is the equation of an ellipse. If there had been something subtracted here with the x or subtracted from the y, that would make a different center. But since I had nothing being subtracted, the center is 0, 0. 25 is something squared. It's the horizontal distance squared. And 9 is something squared. It's the vertical distance squared. So we had a center at 0, 0. Because this is a 25, we're going to count out 5 each direction, horizontally since it's under the x, and 3 up and 3 down on the y's. And that gives us, oh, a beautiful almost ellipse. But what would we do here? Oh, this is ugly, right? It kind of is. So, what I'm going to do is I'm going to group the variables. Group the variables. So I'm going to put my x's together. And I'm going to leave a little space. I'm going to put my y's together. And since 184 doesn't have a variable, it's going to go to the other side. Now this is a little different than the circles because I have something in front of my variable, in front of my x squared. So I'm going to put that outside and make a big parentheses here. I'm going to factor it from each of those terms. So I'm going to have x squared, and then negative 200 divided by that would leave me with negative 8x plus, factor out a 9. Now remember, I would really like this to be something squared. I would really like this to be something squared. And I want this one to have an x and this one to have a y equals a number. We're going to use that completing the square technique. So here, I'm going to take half of the middle term, and then when it goes back up, it's going to square. So that's plus 16. But it's not really just a 16. There's a 25 on the outside, so I'm actually adding a 25 times 16. On the next one, half would be a 1, squared would be a 1. But that's not just a 1 that I'm adding there, it's a 9 times 1. So I'm going to use my calculator. I'm going to cheat. I'm going to do negative 184 plus 25 times 16 plus 9 times 1. And I get that the other side of the equation is 225. Now, just like I did on the very first example, I'm going to divide both sides by 225. And technically, it's going to divide each of these by 225. And 25 went to 225 9 times. And 9 would go into 225 25 times. So my center is going to be at 4, negative 1. So 4, negative 1. Center is 4, negative 1. And A, this is A squared, so A is 3. That's my horizontal distance. 1, 2, 3. 1, 2, 3. B is going to be 5 because that's 5 squared. 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3, 4, 5. I can't count today. And we get our ellipse. Now, there's a little bit more with an ellipse because we had these, it's not the set of points equidistant from one point. We actually have two fixed, what are called foci. And I invite you to pause this and watch this video because it shows it really well. Now, the way we can find the foci is this formula. C squared equals the absolute value of A squared minus B squared. So on our last example, we had a center of 4, negative 1. A was 3, and B was 5. So this foci, these focal points, we can find them by using this formula. So I'm going to take C squared equals absolute value of A squared minus B squared. 9 minus 25 is negative 16. So that's going to be a 16. So C is 4. Now I have to think about which way the foci would be located. They are going to be along the larger axis. So since the y was the larger axis, I'm going to be going up and down 4 steps. So 1, 2, 3, 4. Here's one of my foci. 1, 2, 3, 4. Here's the other one. So I'm going to take my center and add 4 and subtract 4 from the y value. So my foci, I'm going to need to add 4, so 4, 3, and then subtract 4. So here's some that we're going to graph, and these are the ellipses. The center would be at -4, 2. A is 5 and B is 4. So major axis, which one do you think is going to be a major axis? Well, that's going to be the longer axis. So let's go ahead and graph this. We're going left 1, 2, 3, 4, 5, and right 1, 2, 3, 4, 5. That's the longer axis. So that is 10 long. Ooh. And minor is the shorter one. 1, 2, 3, 4. 1, 2, 3, 4. So the minor axis would be 8 long. Foci. So we're going to use this formula to find the foci. C squared equals the absolute value of a squared minus b squared. And if I look back at the equation, my a's and b's are already squared. So C is 3. Now this was the major axis, so I'm going 3 to the left and 3 to the right. So this point is at -7, 2, and the other one is at -1, 2. I could also find those by subtracting 3 and then adding 3. Does not have the 1 on the right side. So I need to divide both sides by 48. So that would give me x squared over 4 plus y squared over 48 equals 1. My center would be at 0, 0. A is 2, and B is the square root of 48. So I don't know that off the top of my head. So the square root of 48. To graph it, I need an estimation, which is going to be really close to 7, I believe. It's around 6.9. Okay, so 0, 0, left and right 2 steps, and then almost 7, almost 7. So the major axis is the up and down, the vertical one. So it's twice as big as that. So I'm actually going to be very accurate and do 2 times the square root of 48. And the minor axis is 4 long. To find the foci, I'm going to take c squared equals the absolute value of a squared minus b squared. A squared was 4 minus 48. That's negative 44, which is 44. So C is going to be the square root of 44. I'm going to write that a little bit better because that's really 2 squared root of 11. Now I'm adding and subtracting that. So it's adding to the y and subtracting to the y. So that'll be 0 comma 2 squared root of 11 and 0 comma negative 2 squared root of 11, because I'm going to add to the 0 and subtract from the 0. Last example, and it's the doozy one. So when we're given these, we want to group our variables. Then I'm going to factor out the leading coefficient. Half, and then square it. But I'm not just adding a 4, that's 4 times 4. Half, square it. But it's not just a 25, it's a 25 times 9. And I get 36. I'm going to divide by the 36, so I get a 1. So my center is going to be 2, negative 5. A is 3, B is 2. A was 3, B was 2. Major axis is the longer one, so that would be 6 long. The minor axis is the shorter one, it's 4 long. The foci are going to be left and right. So I need to find how far away the foci are. Oops, that's supposed to be an absolute value. A squared minus B squared. And I'm adding and subtracting that to the x value. So 2 plus the square root of 5 and 2 minus the square root of 5.